solve the equation, and check the result. We have a rational equation here, right? And rational equations involve fractions of things, and fractions of things are harder to solve than just a polynomial equation, right? So why don't we go ahead and rewrite our rational equation as a equivalent, or mostly equivalent, polynomial equation. The way to do that, of course, is to get rid of our denominators, and the way to get rid of denominators is to do some multiplication. And I can multiply, this thing here by anything I want, as long as I multiply the whole side by that thing, and multiply the other side by that same thing. So if I want to get rid of this x plus 2 in the denominator, I'll just multiply by an x plus 2 over here. Of course, to do that, I've got to multiply by the same thing on the other side. If I want to get rid of this x plus 3 over here, I'll do it. I'll multiply by x plus 3. Right, that'll get rid of that x plus 3. Of course, to multiply by x plus 3 over here, I've got to multiply by an x plus 3 over there. All right. So this will cancel with that. That will cancel with that. I'd also like to get my x squared plus 5x plus 6 on the right-hand side to cancel. So I'd want to multiply by x squared plus 5x plus 6, which I don't have enough room to write. But we're in luck, because in this case, the factors of x squared plus 5x plus 6 happen to be x plus 2 times x plus 3. Right? X times x is x squared. 2 times 3, positive 6. 2x plus 3x is 5x. So I'm already multiplying on the right by x squared plus 5x plus 6. So these two things taken together will cancel with that one thing. Right? So those will cancel. And on the right, I just have a 6. Let's write that. 6. On the left, what do we have? Well, we have to be a little bit careful with our canceling. I can't just say, oh, the x plus 2 cancels there with that, and the x plus 3 cancels there with that, and I have 4 minus 3. That doesn't work. Why doesn't that work? Well, because I'm multiplying the whole fraction here, both terms, 4 over x plus 2 minus 3 over x plus 3, multiplying the whole thing by these two things. So I take these two things, multiply there. I take these two things, multiply there. So when I do this first multiplication times the 4 over x plus 2, sure, my x plus 2 is going to cancel there, and I'm left with a 4 times x plus 3. Let me write that down. 4 times x plus 3. Minus, all right, now I have to take, again, these two things and multiply them by 3 over x plus 3. Well, it cancels now. The x plus 3 cancels with that x plus 3. I'm left with a 3 and an x plus 2. So it's going to be minus 3 times x plus 2. We get that. All right. So now let's try and solve. I got a polynomial equation. Let's just multiply things out, combine like terms, get things equal to 0, factor, solve, etc. 4 times x is 4x, plus 4 times 3, 12, minus 3 times x, minus 3 times plus 2 is minus 6. Don't forget to distribute that negative, right? Equals 6. Let's subtract 6 from both sides. If I subtract 6 from the right, I'm left with a 0. If I subtract 6 from the left, I get a negative 12. Here. Oh, I also had a positive 12 there. Hey, that's great. So I have a 12 minus 6. I subtract another 6. Why don't I write that down? Subtract 6. Subtract 6. So I have a positive 12 minus 6 minus 6. That's 0. 4x minus 3x. That's 1x. I have x equals 0 as my solution to this equation, right? And now this whole check your result thing, this is really a matter of, is this an extraneous solution or not? Right? Assuming I did my math correctly, as long as it's not an extraneous solution, that is a solution that makes the denominator anywhere there be 0, as long as that's not the case, as long as x equals 0 is part of the domain, then this is going to be a solution, so I don't have to do the arithmetic. We check real quick. X equals 0. It's defined in any of these places. Right? I'm never trying to divide by 0, so this is going to be a solution. That's a good enough check. If you wanted to do a little more, you could actually physically plug it in. 4 over 0 plus 2 minus 3 over 0 plus 3. That equals 4 over 2 is 2. 2 minus 1 is 1. On the right, we have 6 over 6, 1.